Hello everyone, I'm Chaerin from Seoul National University, and I'll introduce you our recent paper, Leveraging Off-the-Shelf Diffusion Model for Multi-Attribute Fashion Image Manipulation. This is the collaboration of Seoul National University and Naver. Our target task is attribute editing, specifically on fashion images. There are several motivations for our work. Prior GAN-based attribute editing methods were not scalable as they only supported few target attributes and required separate training procedures for each datasets. Recently, diffusion models have demonstrated outstanding performance in a wide range of generative benchmarks, both in terms of sample quality and diversity. And these models, when combined with classifier guidance, we can defer the capacity to reason about different attributes to the classifier while employing a powerful generic diffusion backbone. And also, annotated fashion image datasets are of relatively small scale, and we found that it's generally easier to train a classifier than a generative model with limited data. Our framework builds on top of a recent paper called Blended Diffusion. And the high-level idea is that given a condition, mask, and image, the diffusion model gradually blends the foreground and the background. They synthesize the foreground object with classifier guidance. This is the overall framework. We first leverage a pretrained VIT to provide classifier guidance, and in order to do that, we train an attention pooler on top of a frozen VIT model to provide semantic guidance and cross-attention map. This cross-attention map is used to obtain the salient region, and all the remaining regions are classified as the background. So our diffusion process is guided with first the target attribute logit, which is the classifier loss, and second, the background preservation loss. Here, we show some quantitative evaluations. These are empirical findings from our experience of fine-tuning the VIT model. Because we have a relatively small-scale dataset, we found that training the attention pooling layer only produced the best results. These are some qualitative results. On the left, we can see that our framework successfully produces images of high qualities and the target attributes. And on the right, we can observe that our framework is capable of simultaneously altering multiple attributes. And these are ablation experiments. On the left, we can see that higher classifier accuracy leads to better guidance, both in terms of the semantic signal and the class activation map. And on the right, we can see that with simpler operations, we can reduce the diffusion sampling steps, and hence we could reduce the total inference time and computation cost. So in conclusion, we propose a generic attribute editing framework that employs a single model, and this framework leverages a pre-trained diffusion model and also a pre-trained VIT backbone. And this supports local editing operation without any explicit spatial mask. Thank you very much for listening.